Okay, so draw a suitable graph to verify Joule's law. That's what you said, wasn't it? Part 3, I think. So Joule's law is P is equal to I squared or. Now, you kind of have to take into account what's happening below this as well, because it does start asking for specific heat capacity. Okay. Okay, well, before I do anything, it's I squared. So you're going to have to take that line and square everything. Yeah, so you'll have 1 squared for the first one. So this will be 1, 2 squared will be 4, 3 squared will be 9, etc. Can't do 3.5 squared in my head. Yeah? So that's that anyway. Now, power is energy over time. And then the energy here is heat energy. And we're getting specific heat capacity. So energy is mc delta theta over time equals I squared or. Okay, now I can see the second. So this delta theta is what this needs to be. Sorry, my highlighters are very thick. So it says up here that room temperature is 17. So we don't want the temperature, we want the change in temperature. So it's going to be 19.2 minus 17, so 2.2. 26.1 minus 17, what's that? 9.1, etc. Yeah, so you're going to have to do each of the numbers in the list minus 17. That's what you plot in your graph. Now, which way will we plot it? So the last question asks for specific heat capacity, which is this. Yeah, so I'm going to isolate that. So I am going to multiply by t, which will cancel that, and multiply by t over here. So now I have mc delta theta equals I squared or t. And then I'm going to divide by m and delta theta. And then you have to do that over here. So divide by m and divide by delta theta. Okay, so C then, which is what we want, is I squared over delta theta. This is multiplied by R and T, and this is multiplied by M. So this is going to come from your graph, because they're the two quantities on the graph. And it's always rise over run, which means that goes on the y-axis and that goes on the x-axis. So then when you get your slope, this is... So you plot the graph with I squared on the y-axis and delta theta on the x-axis. And then you do your slope formula or rise over run, whichever you want. Sorry, I'm moving through here. So part 4 is calculate the slope. So in part 4, you will calculate the slope. And then when you're actually using this in part 5, it will become whatever you got for the slope. And then you multiply that by the resistance, which is here, so that's 8.5. The time, it must have given us a time. Oh, there, 3 minutes, 180 seconds over the mass, 350, yeah, so 0.350 kilograms. And then that will give you whatever the specific heat capacity is. Yep, hope that makes sense.